Hello and welcome to helpyourmath.com. In this video, we're going to look at solving absolute value equations. We've already looked at a few examples. Here's just examples that increase in difficulty as we go. And keep in mind, when we have absolute value equations, the goal is to isolate the absolute value term and then get the absolute value by itself. And then once you have the absolute value by itself, you can determine the number of solutions based on whether it's equal to something positive, in which case there's two solutions, 0, in which case there's one solution, or negative, in which case there is no solution. So just make sure you do that quick check before you start just pumping out the math when maybe you didn't need to. Okay, so we are going to solve each equation, graph the solution, and when we graph the solution, we graph it on a number line, and write the solution in interval notation. Okay, we already have the absolute value expression by itself, and it's equal to something positive. I'm expecting two solutions. One solution is when what's inside the absolute value, 3x minus 4, is equal to positive 8. Or what else could inside the absolute value, because what else is, who else's absolute value equals 8 besides 8 itself? It could also be equal to negative 8. So we set up the two equations and then we solve them separately. So here I'm going to add 4 to both sides. That gives me 3x is equal to 12. Divide both sides by 3. And we get x equals 4. Over here, I add 4 to both sides. I get 3x equals negative 4. Divide both sides by 3, and I end up with x equals negative 4/3, or if you want to, you can write it as negative 1 1/3. Okay, we solved it. That was part 1. Part 2, graph this. So we're going to graph it on a number line, and I need to go as little as negative 2. 1, 2, 3, 4. And negative 1 1/3, that's in between negative 1 and negative 2, a little bit closer to negative 1. And 4 will be just over 4. And in interval notation, because these are discrete points, we can just say x equals negative 1 1/3, comma 4. And that would be it. Voila. How about our next example? We have 10 is equal to 2 times the absolute value of 3x plus 7. So the term containing the absolute value is by itself, but there is something being multiplied to it as a coefficient besides 1. We're going to divide both sides by 2. You cannot distribute the 2 inside the absolute value bars. That violates the rules of absolute value bars. We must move that coefficient to the other side. This gives us 5 is equal to the absolute value of 3x plus 7. And if you're uncomfortable with the absolute value being on the right-hand side, you can move it to the left-hand side. Commutative property tells us that that's okay, so go for it. Now, we have the absolute value is equal to something positive. What does that tell us? There should be two solutions. One is when what's inside this expression, 3x plus 7, inside the absolute value bars equals 5 itself. Or what else could the expression inside the absolute value bars equal? What else has an absolute value of 5? Also negative 5. So we set up our two equations, we solve each one. Subtract 7 from both sides, we get 3x equals negative 2. Divide both sides by 3, and we have x equals negative 2/3. Over here, we're going to subtract 7 from both sides. We get 3x equals negative 12. Divide both sides by 3, and we end up with x is equal to negative 4. Okay, so we solved. That was step 1. Step 2, graph. So when we graph it, I need to go as far as negative 4, and then negative 2/3 is in between negative 1 and 0. It's going to be a little bit closer to negative 1, and we'll put a closed circle over negative 4. And lastly, interval notation, we would say x is equal to, they're discrete, so we use braces. Put the smaller one first, negative 4, negative 2/3. And we are done. Now, we're doing this, and you might be saying, wait, I want to know for sure that these are the right answers. I don't know you, I don't trust you. Well, thank you for that, first of all. Second of all, absolutely, you can plug those in and make sure that when you plug each one in, you end up with a true story, with a true statement. So if we plug in negative 4, we get, does 10 really equal 2 times the absolute value of 3 times negative 4 plus 7? Well, this is negative 12. Negative 12 plus 7 is negative 5. The absolute value of negative 5 is positive 5, and we end up with 10 equals 2 times 5. Great. That one works. If we plug in negative 2/3, we get 10 equals 2 times the absolute value of 3 times negative 2/3 plus 7. Okay, this would be 3 over 1. Those cancel. This is negative 2 plus 7. Negative 2 plus 7 is 5. The absolute value of 5 is 5 times 2 is 10. So they both worked out. Yay! A few more examples. What's going on with this one? First, let's get this absolute value by itself. Let's subtract 13 from both sides. We get the absolute value of 3x minus 2 is equal to negative 16. The absolute value is equal to something negative. What does that tell us? There is no solution, right? You can't take the absolute value of something and equal something negative. So this one has no solution. We would represent that on a number line by just having a number line and not marking any points because there's no solution. So it would just be a blank number line. In interval notation, you can open up a set of parentheses and immediately close them. Don't put anything inside those you can open up braces, close the braces because nothing's going inside the braces. Or what you could do is you could say it's the null set, which is like a 0 with a slash through it. That's it for this one. Moving on. Go ahead and try these two examples, pause the video, see how you do. Okay, for the first one, you might be thinking, wait a minute, it's equal to something negative, no solution. But get the absolute value by itself first before you make that judgment. First thing we're going to do is subtract 5 from both sides. And we end up with negative 3 times the absolute value of 2 minus 6x is equal to negative 15. Divide both sides by negative 3. We get the absolute value of 2 minus 6x is equal to positive 5. It's equal to something positive, so there are two solutions. One is when what's inside the absolute value is equal to 5. The other is when what's inside the absolute value is equal to negative 5. Here we're going to subtract 2 from both sides. We get negative 6x is equal to 3. Divide both sides by negative 6. And we get x is equal to, this is a positive divide by negative, which will be negative. 3 over 6 simplifies to 1/2. For this one here, where I'm running out of space, I'm going to subtract 2 from both sides. We're going to get negative 6x is equal to negative 7. Divide both sides by negative 6. And we end up with negative over negative is positive, 7 over 6. Okay, so here's part 1. Part 2, let's graph these guys on a number line. So negative 1/2, I need negative 1, 0. 7 over 6, I need in between 1 and 2. So this is exactly halfway between negative 1 and 0. 7 over 6 is really close to 1, much closer to 1 than it is to 2. And then in interval notation, we're going to say negative 1/2, comma, 7 over 6. That looked weird. Let's try that again. 7 over 6. Okay. In this next example, we have the absolute value of 4x minus 8 is equal to the absolute value of negative 8. Wait, I know what this is. What's the absolute value of negative 8? That's just 8. So we're going to say the absolute value of 4x minus 2 is equal to 8. It's equal to something positive. Absolute values by itself. There are two solutions. One is when this thing, 4x minus 2, is equal to 8. The other is when 4x minus 2 is equal to negative 8. Solve each one separately. So here we're going to add 2 to both sides. We get 4x is equal to 10. Divide both sides by 4. And 4 doesn't go evenly into 10, but they are both divisible by 2, so we can write it as 5 over 2. Or you can call that 2.5. Over here, let's add 2 plus 2 plus 2. We get 4x is equal to negative 6. Divide both sides by 4. And again, 4 doesn't go into negative 6, but negative divided by positive is negative. They are both divisible by 2, so I'm going to write it as negative 3 over 2. So I have one solution here and one solution here. Let's graph these on a number line. On my number line, I need to have negative 2, because negative 3.5 is negative 3 halves is in between negative 2 and negative 1. And over here, I'm going to need to go up to 3. So I need right here will be my negative 3 over 2, and 2.5 will be right here. And lastly, in interval notation, we're going to open this up, use a brace because they're discrete. I'm going to be consistent. I'm going to rewrite it as negative 1.5 and 2.5. And that's it for this one. One more example. I didn't want you guys to try this one because it's a little bit weird looking. We have an absolute value is equal to an absolute value. Now here's the deal. The absolute values, there are two solutions to this. One is when you just ignore all absolute value signs. So one possible solution is when 2y plus 5 is equal to 7 minus 2y. The other thing that could happen is that one could be the positive version of the number and one could be the negative version of the number, in which case we would want to say that one side stays the same while the other side could be the negative of that. So we set one side, keep it the same, one we put a negative in front of the entire expression. And these are the only two possible solutions, so we're going to solve each one separately. First I'm going to add 2y to both sides and subtract 5. That gives me 4y is equal to 7 minus 5 is 2. Divide both sides by 4, and we end up with y equals 2 over 4, or y equals a half. Or what happened over here, we need to distribute that negative sign. So we get negative 7 plus 2y. And, oops, wait a minute. I'm going to subtract 2y from both sides. And I'm going to subtract 5 from both sides. And here I get 0. And here I get negative 12. Oh, just kidding. There's only one solution because this one didn't pan out. There could have been potentially two solutions if this didn't end up being something weird, but it was something weird. It was a false statement. So we only have one solution, and that is 1/2. Usually there is a second solution. So this is a weird problem in that there's not. And we would be able to solve that one. Okay, so here we have a half, and we would say y is equal to, brace, because then we have our one discrete solution, y is equal to a half. These have been a lot of examples of looking at absolute value equations. Thank you for stopping by.